Now we're going to look at triangles. We've looked at segments, at rays, at angles, and all this other terminology, and we're going to put it all together and look specifically at triangles. So to start with, what is a triangle? Everybody knows it's got three sides and all the angles add up to 180. Right? A couple things to keep in mind. Whenever you're talking about the angles or the vertices of a triangle, you can say angle A, angle B, or angle C. Sometimes you might need to be more specific, and if that's the case, you have to make sure that you use three letters. So I might say angle ABC, and whatever is in the middle is the angle you're referring to. So in this case, I could say angle A or angle BAC, or I could even say angle CAB. All of those are referring to angle A down the bottom left. Whenever you're referring to the sides, a general rule of thumb is you'll have a capital letter for the angles, and then the side opposite that angle is going to be the lowercase letter. So in this case, I have a capital A, and opposite the capital A is a lowercase a. Opposite the capital B is a lowercase b, and opposite the capital C is a lowercase c. You can also classify them by naming their sides. So I have side AB. Now this is a segment, so we put our segment bar above it to classify it as a side. So you have side C, which is the same as side AB. Side B is the same as AC, and side A is the same as BC. So classifying triangles by angles. You can have an acute triangle, an obtuse triangle, a right triangle, or an equiangular triangle. So an acute triangle is where all angles are less than 90 degrees. An obtuse triangle means that only one angle is obtuse and the other two have to be acute. And a right triangle has one right angle and the other two are acute. And then equiangular is where all sides or all angles are the same. Now equiangular gets specific because I know that all of the angles add up to 180. That means there's only one option for an equiangular triangle, and that's when all the angles are 60 degrees. All right, you denote your angles with curves, and you denote right angles with boxes. It kind of got cut off at the bottom there. But if I have this triangle, right, I can say that if it's an equiangular triangle, all of them are the same. I can give all of them one curve. Okay, or if I wanted to say that only two of them were the same, I might give two of the angles two curves. Or if all three of them are different, I'm going to put a different number in all three angles. This tells me that they're not the same. And then our right angles, if we have a right triangle, we put a box in it. So that would be a right triangle. Then we can classify by sides. So if we classify by sides, you can have equilateral, where all the sides are the same, isosceles, where at least two sides are the same, and scalene, where none of them are the same. Okay, so then we have the question, is an equilateral triangle an isosceles triangle? Yes, because there are at least two congruent sides. An isosceles triangle is not always an equilateral triangle because it means that only two sides have to be the same. In equilateral, you have to have all three. All right, you denote sides with a dash, and again, some of it got cut off. But just like we talked about with the angles, if I have an equilateral triangle, I can put a dash on all three sides. Because they all have one dash, that means that they're all the same. If maybe only two sides were the same, I might have one with two, and then the other two sides both have one dash. That tells me that those two sides are the same. Or they may all be different, so I might have a 1, a 2, and a 3, telling me that all three sides are different lengths. So if I want to classify these triangles, in this one up here, all I'm given are the angles, which tells me that I have a 100-degree angle, which is bigger than 90. So this triangle must be obtuse. And because all of these angles are different, that means that all of my sides have to be different. So I do also know that it's scalene. If I know the triangle in the bottom, I know that all three angles are different and all three sides are different because none of them have the same number of dashes or curves. So that means that this one is just scalene. Now, even though it looks like this is probably obtuse, I cannot go by what I see. I can only go by what I'm given. So if I don't know anything about these angles, all I know is that all three sides are different, so it's scalene. This triangle over here, I have 17.1 and 17.1, and then 13 is different. And then my angles are the same, and all of the angles are less than 90. So that means that I can say that this one's acute as well as isosceles. The triangle angle sum theorem, that's what tells us that the angles add up to 180, right? Which everybody kind of knows already, but this theorem is where it comes from. Because of this theorem, we can answer simple questions like this one, where I know that angles are 70 and 40. I want to know what the last one is. Well, if I add 70 and 40, that's going to give me 110. And I know all of them have to add up to 180, so 180 minus 110 gives me 70. All right, just subtract them all from 180. Then we have problems like this, where I know the three expressions for my angles, and I want to find x, or what each angle is. So I'm going to add up all my angles and set it equal to 180. So I have x plus 10 plus 2x plus 20 plus 2x minus 5 equals 180. I have x, 2x, and 2x to get 5x. I've got 10 plus 20 to get 30 minus 5 to get 25. Subtract 25, so we get 5x equals 155. And divide by 5, x equals, and we get 31. Alright, if I wanted to know what the angles were, I just plug x back in. So 31 plus 10 gives me 41. 2 times 31 is 62, plus 20 is 82. And 2 times 31 is 62, minus 5 is 57. And then 41, 82, and 57 should add up to get 180. Because of the triangle angle sum theorem, that tells us two things that kind of stem from this theorem, right? If all my angles can add up to 180, that means that there can be at most one right or obtuse angle in a triangle, right? If I have an angle that's 90 or more, I can't have any other angles that are 90 or more, or I'll go over my 180 limit, right? And then also, acute angles of a right triangle are complementary. Remember, complementary means they add to 90 degrees. So if I have a right triangle, that means I've got a 90-degree angle. That only leaves 90 degrees for my other two angles, because 90 plus 90 is going to give me my 180. So that means that those two angles are complementary. Exterior angle theorem. That just tells us that the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So exterior means outside, interior means inside. So number 4 down here, this is my exterior angle. 1, 2, and 3 are interior angles. So let's see how this works. If I were to maybe say that angle 1 was 50, and maybe angle 2 is 60, 50 plus 60 is 110. So 110 from 180 is 70. So that leaves 70 for angle 3. Well, I know that angle 3 and angle 4 are supplementary because they're a linear pair. They make up this line PS. Right? So if I were to figure out what 4 was, I would take 180 minus 70, and that's going to give me 110. Right? Well, now if I look at the relationship between 50 and 60 and 110, 50 plus 60 is 110, and that's what my exterior angle is. Right? So for this case, angle 1 plus angle 2 equals angle 4. Now, just to get a little more mathematically correct, typically whenever we're talking about the measure of these angles, we're going to put a little m out front. So we'll say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4 by this exterior angle theorem. So now I want to find x, where I know that 25 and x plus 15 are the interior angles, and then 3x minus 10 is my exterior angle. Now pay attention that exterior angle theorem we just looked at says it's equal to the measures of the remote interior angles. The remote, if you think about being on a remote island, you're far away. So if I'm looking here at my exterior angles, the two angles that are farthest from it are going to be the ones not touching. Alright, so that means that the sum of these two has to give me my exterior angle. So my equation could be 25 plus x plus 15 has to equal 3x minus 10. So I have 25 and 15, so I get x plus 40 equals 3x minus 10. Right? If I subtract the x over, 40 equals 2x minus 10, add 10, 50 equals 2x, and then divide by 2. So x equals 25. All this one wanted me to find was x, so there's my answer. Now keep in mind, I was solving for x, so even though we have this 25 down here, doesn't mean that my angle is 25. It means that x is 25. So if I plug x in, I get 75 minus 10, or 65. And that is it for this video.